For this set of questions, we are given inequalities and asked to construct the solution set and express it in interval notation. So the first one I have is 2x plus 1 is less than or equal to 13. And I'm going to do this a little bit differently than the way it's typically done. I prefer a testing points strategy. So what I do is I solve it as an equal. I say 2x plus 1 equals 13. What is x? So we quickly solve that equation. And we get x is 6. We look at our inequality sign. It is less than or equal to, which means we include the 6. That tells me I need to use a solid dot. So I lay out a number line. 6 is what I call my cut point. It is a solid dot because it is less than or equal to, and I'm going to test numbers in each interval to the left of 6 and to the right of 6. And I always try to plug in 0 first. So where is 0? Is 0 to the right of 6, 7, 8, 9? No. 0 is to the left. Then I pick any number I want to the right of 6. Could be 7, 8, 9, 10, whatever. And I test to see if the resulting statement is true or if it's false. So if I plug 0 in for x, that would give me 2 times 0 plus 1 less equal 13. And the result is 1 less equal to 13. No, that's not true. Now 10 is my test number for that half of the line. So is 2 times 10, check it. Of course that's true. 1 is less or equal to 13. Whoops. Of course that's true. Over on this side, 2 times 10 plus 1 is that less equal to 13. 20 plus 1 less equal 13 is 21 less equal 13. That's no. So that tells me which way I have to shade. Shade towards the yes and don't shade towards the no. So that is my solution set. Now doing that in interval notation, we always go left to right, starting at negative infinity, going to 6. It includes that point. So that is my answer. Now that's a little longer than the traditional method. Let me show you the traditional method now, and then I'll explain why I prefer the method I just showed you. 2x plus 1 less equal 13. Here's the traditional method. We subtract 1 from both sides. And then you ask yourself, when you subtract 1, do you have to change the sign? You got to think about that. You divide by 2. When you divide by 2, do you have to change the sign? You got to think about that. If you do it correctly, it's done in a couple steps. X is less equal 6, and then you can go ahead and graph it. The thing you've got to remember about your traditional method is whenever you multiply or divide both sides by a negative number, that's when you change the sign. We didn't. We added a negative number. We divided by a positive number, so we never had to change the sign. But if you use the traditional method, you've got to keep that in mind. Whenever you multiply or divide by a negative, you have to change the sign. I prefer the test point reason for another situation, because when we take advanced courses in algebra, we do absolute value inequalities, we do polynomial inequalities, we do rational inequalities, and all of those techniques use some variation of testing points. So I think it's good to get used to that while we're doing these sorts of inequalities. What's our next example? We have 5 minus 2x greater than 11. So I see greater than, and right away I remember, okay, I'm not going to include the point. That's going to be a round circle of sorts. So using my testing point strategy, 5 minus 2x equals 11. Subtract 5. Negative 2x equals 6. Divide by negative 2. X equals negative 3. And it's greater than, so it is an open circle. So here is negative 3 with an open circle. Now, we want to place 0. Is 0 to the left of negative 3 or is 0 to the right of negative 3? I hope you chose that one. To the left of negative 3 would be negative 4, negative 5, negative 6, negative 7, whatever you want to use. Pick a representative. I like to test 0 first. Let's see if 0 is true or if it's false. 5 minus 2 times 0, is that greater than 11? 5 greater than 11? No. We'll try -7 on this side. Let's see if we get something greater than 11 there. Is 5 minus 2 times -7 greater than 11? Is 5 plus 14 greater than 11? Is 19 greater than 11? That's yes. So you shade towards the yes side, you do not shade towards the no side. So this is what we get. So even though that was a greater than problem, we are shading in the left direction. In interval notation, from left to right, left, where are we at? We are at -7. Going to what? Going to -3 with -7, excuse me, -infinity. That's kind of a big mistake. All the way to the left, it goes all the way to -infinity. And then it goes to -3 with a round bracket. All the way to the left. So -7 is the test point, but -8, -9, -10 are all in the set as well. So -infinity to -3 round brackets on either side is my answer. Now here is the traditional approach to this problem. 5 minus 2x greater than 11, subtract 5. Do you change the sign when you subtract 5? The answer is no. -2x is greater than 6. Now I want to divide by -2. Do you change signs if you divide by -2? The answer to that is yes. So eventually I would get x is -3, but you've got to always be asking yourself, is that a situation where the sign has changed? And I think that can be dangerous. So that's why I prefer the testing point strategy. Okay, let's see what else I have to do. 3 minus 2 times x plus 5 is less equal x plus 14. Okay. So I want to first do it as an equal. Grab a piece of scratch paper. Let's do it as an equal first. So 3 minus 2 times x plus 5 equals x plus 14. 3 distribute, minus 2x minus 10 equals x plus 14. 3 minus 10 is -7. Minus 2x equals x plus 14. Let's add 2x to both sides. -7 is 3x plus 14. Let's subtract 14. -21 is 3x, and then let's divide by 3. And we get -7 is x. And then we see our original had less than or equal to, right? So that means it's going to be a solid dot. Less equal was our symbol. It'll be a solid dot at -7. I've got a test on either side. So I'm going to lay out my number line with -7 at a solid dot and then decide which way am I going to shade. So here we go. Here is -7 with a solid dot. Now I like to put in 0 first. Is 0 to the left? Here would be -8, -9, -10, -11. Here would be -6, -5, -4, -3, -2, -1, 0. So 0 is over on this side. Pick anything I want to the left of -7 and go with -8. I like to test 0 first. So let's plug in 0 for x, see if it's true or if it's false. 3 minus 2 times 0 plus 5. Is that less equal 0 plus 14? 3 minus 2 times 5, is that less equal to 14? Is 3 minus 10 less equal to 14? Is -7 less equal to 14? Yes, owing 7 is worse than having 14, that's yes. So I believe I'm going to shade to the right. But let's make sure, let's plug -8 in and make sure that one is false. 3 minus 2, because you don't usually have both of them true, although that can happen, as we'll see. -8 plus 5 less equal -8 plus 14. -8 plus 5 is -3. Less equal -8 plus 14, I believe, is 6. -2 times -3 is 6. 3 plus 6 less equals 6, 9, less equals 6, that's no. So I don't shade towards -8, I shade towards 0. So it looks like this. In interval notation, square bracket, -7, comma, out to plus infinity. Never actually gets to infinity, that's why that's a round bracket. So that's that strategy. Now let me show it to you how we would do it using the traditional strategy. But you've got to remember, if you multiply or divide both sides by a negative, you've got to switch the sign. But you have to always ask yourself that as you're working through the process. So here's our traditional strategy. 3 minus 2x minus 10 less equal x plus 14. -7 minus 2x less equal x plus 14. I don't know, maybe I'll add 7 to both sides. That does not require me to switch the signs. Then I get -2x less equal x plus 21. Maybe this time I'll subtract x from both sides. And I get -3x less equal 21. Now I want to divide by -3, but if I divide by -3, I absolutely have to switch the sign. So I get x is greater than or equal to -7. So we can do it that way, it's just dangerous. And then we have our square bracket, -7 to plus infinity. And again, the other reason is, again, keeping track of multiplying or dividing by a negative, but also getting us prepared for more advanced inequalities in later courses. And I believe we have one more question in this set to do. Let's try that. We have 3 plus 2 times x plus 7 less 4x minus 2 times x minus 9. Okay. So using my preferred strategy, I'm going to solve it as an equal. So we say 3 plus 2 times x plus 7 equals 4x minus 2 times x minus 9. Distribute. 3 plus 2x plus 14 equals 4x minus 2x minus 2 times minus 9 plus 18. 14 and 3 is 17 plus 2x equals 2x plus 18. Subtract 2x. And I get 17 equals 18. Well, there are no cut points. It's never true. So what that tells me is I don't have a left and a right side. All I have is everything. Either it's always true or it's never true. Those are my two options. So the way I visualize this is I don't have any cut points, no open or closed dots. I'm just going to pick a point in the middle and I'm going to see, is that true or is that false? So if I plug in 0, I get 3 plus 2 times 0 plus 7 is less than 4 times 0 minus 2 times 0 minus 9. 3 plus 2 times 7, is that less than 0 minus 2 times -9? Is 3 plus 14 less than -2 times -9? Is 17 less than 18? Yes, it is. It's true for 0, so therefore it'll be true for everything. So my answer is all real numbers. If we want to use interval notation, left-hand side, -infinity, to the right-hand side, +infinity. So I really think that my strategy of testing points that we did here is also helpful to solve the sorts of problems that either have all real numbers or no solution possibilities as well.